Hey everyone, thanks for tuning in. In the last months, I've been increasingly interested in the Commodore 64 microcomputer from the 80s. By today's standards, it's a very limited and obsolete machine, but in recent years, it has picked up new steam thanks to a growing and dedicated community of developers and modders that are determined to keep this platform alive, both with new software and games being released almost every week, and new hardware components to either replace broken parts that are no longer available, or to enhance the computer's capabilities. So I decided to step in and do my part. I have a series of hardware mods and accessories in mind that I would like to develop for this computer, but in this video we're going to take a look at what to me is the biggest issue of all, the power supply. This thing is huge, heavy, and heats up quite a bit, even when the computer is off. Not to mention that from what I can read online, these power supplies are dying and they aren't very easy to replace. I'd like to be able to power the computer with a modern switching power supply that anyone could purchase, such as this 12 volts 3 amp power supply that I've found. And for this we need to modify the power circuit within the computer itself. The C64 takes two input voltages, 5 volts DC and 9 volts AC. The 5 volts rail was the standard voltage to power most digital components back in the 80s, while the 9 volts AC was likely chosen because of how simple it is to rectify and multiply an AC voltage in order to generate a number of additional internal rails. Nowadays, however, small and high-performance switching DC-DC converters can be purchased for pocket change, so we're going to use some to generate all the necessary internal voltages without the need of an AC supply. If we look at the C64 service manual, we can see that we effectively need to produce 4 voltage rails. 9 volts unregulated is simply the rectified 9 volts AC input, which is actually closer to 11 volts DC. I specifically chose the 12 volts power adapter so that we can power the 9 volts unregulated rail directly from the input power supply. 5 volts was supplied directly by the original power supply and from my measurement draws about 800 milliamps. We'll have to generate this rail with a step-down switching converter from the 9 volts unregulated rail. 5 volts CAN is an additional cleaner 5 volt supply dedicated to the VIC-2 graphics chip and is generated with a linear regulator starting from 9 volts unregulated, drawing about 400 milliamps. We can actually leave this part of the circuit unchanged, as we will be already supplying about 11 volts to the 9 volts unregulated rail, like in the original circuit. 12 volts is the power for the SID sound chip, and only draws a few hundred milliamps. This voltage actually isn't the same in all revisions of the board, as some newer devices used a different chip that was powered with 9 volts DC. This voltage is originally generated by rectifying and then multiplying the 9 volts AC with a charge pump, and then using a linear regulator to get to a clean 12 volts DC. Therefore, we'll need a step-up switching converter to generate about 15 volts from our 12 volts input in order to feed the 12 volts linear regulator with a voltage high enough for it to function properly. There are, however, a couple of important limitations with this approach. First, the original 9 volts AC input is also fed to a comparator and used to generate a 50 or 60 Hz square wave that is used by some programs to keep track of time. The proposed approach does not provide this functionality, however from what I can tell I should still be able to run 99% of games and applications. Anyway, I'm planning to solve this by generating a 50 or 60 Hz square wave internally with a small microcontroller. In the original hardware, the 9 volts AC input is forwarded directly to the user port. Since we'll be supplying a DC voltage instead, it is likely that some user port accessories won't work properly if they make use of charge pumps or negative voltages internally. However, I don't think I'll ever be using the user port on this computer, and it seems that nowadays user port accessories are not the primary focus of the community, so I think I can live with this limitation. So I went ahead and bought a step down and a step up converter off of AliExpress. These usually go for under $1 each and will get the job done just fine, at least for a proof of concept. First of all, I adjusted the output voltage of the step down converter to 5 volts and the step up converter to 15 volts. One thing that will come in handy is that ground is shared between input and output in both converters, so we need to attach only one ground terminal to the C64 board. I decided to remove these 3 large capacitors to make space for the new converters, since we'll be adding our own buffer capacitors to the circuit anyways. The step-up converter will go here with its output close to the 12 volts regulator, while the step-down converter goes here with its output close to the 5 volts rail. After completing the mod, I did some testing and I noticed that the voltage ripple on the 5V supply was a little high, around 200 mV peak to peak. This is due to the fact that the converter switches at the relatively low frequency of about 70 kHz. In order to mitigate this, I removed C91 and C92 and replaced them with a large 4.7mF electrolytic capacitor on the 5V rail. I also added a 2.2mF capacitor on the rectifier's output for good measure, which is attached to ground on this terminal of C95 and to 9V unregulated on this terminal of CR6. And I also went ahead and replaced the original power connector with a barrel jack fitted on a metal ring, which is connected to the pins that were originally assigned to the 9V AC input. It doesn't matter which way I connect it because this voltage is anyway rectified. It's time to power up the computer and verify that everything is working. Here we're having a look at the voltage ripple on all supply terminals, and we see that it's reasonably low, especially on the output of the linear regulators. And here I'm finally playing some Old Tower on my DC-powered C64. Sadly, the SID sound chip in this machine is dead, so I can't let you hear the awesome soundtrack. Now that the power supply issue is out of the way, I can finally tackle my second biggest issue with the C64, the joystick. But that's a topic for another video. Anyway, I hope you found this video interesting, thanks again for watching and see you all next time.